What's up guys, Shawnthebro here, and today we're going to be going over part 4 of the advanced Minimap, little map in the bottom left hand corner there, for the first person tutorial series. And so what we're going to be doing today is actually moving the icons to where they should be on the map, not just placing them at arbitrary locations, and we're going to be allowing them to only go within the bounds of the map. So right now, even if they exit outside of the range of the map, they're still at the proper location. They just get locked to that value where they would be off the map. So see, as I walk away from them, they're not leaving the minimap, even though they're out of range of it. They're just shown farther than where the map can display. So we'll be covering all this, and you'll be able to have a minimap with working icons that actually go where they should and clamp to the edges of your minimap. I have a square minimap in another series that I do, the third person tutorial / action RPG tutorial series. If you'd like your minimap to be square like that as opposed to circular like ours is in this series, where ours is meant to be more of like a radar, then feel free to check out that episode. It is very, very similar to how we're doing this, and I'll show you some of the differences in this episode. But just so you're aware, if you're using a circle like I am here, it's going to be a little bit different than the square we used in that series. They are different mechanics, different functionality on how to perform those. Anyway, we can go ahead and get started. But before we do, if you want to get caught up in the series, we are on episode 40 of the first-person shooter tutorial series. So if you'd like to get caught up, I'll link this playlist right here. You can check out every episode, how we got to this point. We still have so much more work to do, but I'm happy with how far we've come. Alternatively, you can go ahead and check out this episode right here. If you're just interested in the minimap, this is the first episode of the advanced minimap for the first-person shooter tutorial series. So you can check out those 4 episodes and you'll be caught up to where we are right now. Okay, so let's go ahead and get started. So what we want to do today is go into our minimap and adjust where the icons are. So the starting place for that is in our overall minimap widget. Okay, so this minimap widget is the one that we put on our HUD, and there's 2 things we have to do here. We had the icons for the enemies different for the icon for the player. So we were setting the horizontal alignment on the player to the center, but the enemies were going to the top and the left. The enemies and the items, they were going to left and top here for the horizontal and vertical alignment. So in create icon for minimap, we're now going to be doing the math to put them in the right spot. So before we do anything, we want to make sure this is set correctly. And so we want to change the horizontal alignment to center again. Because with the new logic in today's episode, we will be able to actually move them and they won't just automatically cover up the player. So there's no reason to do any hacks to make it more visible. So just make sure you reset both of these back to center in the create icon for minimap under the actual minimap blueprint. There's another thing we need to do in here, and that is to grab the size of this widget. Now, when we go to our character HUD, let's go to it. As I said, this is the minimap. This widget right here that we just made these changes in, that is the widget that is on the HUD right here. Okay, and we added that in a previous episode. But the reason this is important is because if you go to your HUD and click on this image, you will have your size here, your size X and your size Y. And that is the size that this widget is. And so we're going to need this to do some math today. And if you want to make your life a little bit easier, you can either keep track of this, write it down somewhere, or make a variable for it. It doesn't really matter because this size probably won't change. So you might not need to make a variable for it. You might be able to use a hard-coded value. But just remember that, remember the meaning of it if you do, because it can be very confusing, some of the math we're doing today, if you're not very familiar with it. So my size X and my size Y are both 300 because I have it an actual circle here, so it's not longer or taller. It's the same the whole way around. It's a true circle. So again, 300 and 300, those are my sizes. So I can go ahead and either write it down, keep note of it, whatever. What I'm going to do is I'm going to go into my minimap widget and I'm going to make a variable here. We will be able to use this variable in the future to change the size of the map if we want to. I have a plan for that because there's a specific mechanic in mind that I want to be able to do, and it will require us to change the size of the minimap So I'm going to put it into a variable. However, depending on what you need, you may not want to do this. That's up to you. What I did is I've gone into my Minimap widget and I've added a new float variable. So you can click plus variable here to do that. Change it to your float type. And I called it size in widget. So it's very direct. And this is going to be the size that it is in the widget. It's pretty simple. Now, if you have a different X and Y size, you can save this out to a vector 2D. Right here, vector 2D. And it will have an X and a Y value. You can put in your two different sizes then. You could put 300 and say your other one was 450. Put 300 and 450. For me, it's staying the same size. It's a circle. So I'm keeping it as a float, and I'm just putting 300 as the size. Okay? And so with that done, we'll be able to keep track of the size on the HUD, which we'll need because we need to know where these icons should be in relation to this widget and in relation to how big this widget is, which also changes where the icons can be displayed and that sort of information. So it's really important that we do have that value. Now we're going to go to our map icon widget. So map icon widget is this icon that we set up in the previous episode where it can take any image. As long as we add the map icon component to anything, such as our enemy, which I can show you really quickly. So we have this map icon component that we added, and we set this as the image. That's why when we play the game, we have these images, because these icons on this enemy are assigned to be this image. So that's the enemy icon. So that's what this widget is really doing, though. It's housing this icon image as well as a few other things and moving it to where it should be. Now, previously, we had not done any moving logic. We had just done this logic in event construct to get the owner to set the brush on this image and then set a reference to the minimap. Setting the reference to the minimap we didn't really use, but we are going to be using it today, so it'll make more sense. So everything in construct is the same. I haven't changed it, but we've added a bunch to event tick, as well as another function that does quite a bit more. So let's start off simple. Let's grab event tick, and this is going to happen every frame. So once you click this, you'll get this node right here. So every frame, what we're going to do is try to update the location of objects on the screen. Now, you know, if you've ever seen radar, you may see sometimes it's not actually every frame. It has a refresh rate that's a lot slower than that. And so you might see enemies in one spot they've already moved, and you won't see their next location until that next update comes around. Right now, this is every frame, so it's basically going to be instant. Whenever something moves, you will see it. Okay, so that's why we're doing this in event tick. And we're going to need to do a lot of math. So I'm going to do my best to explain it here, but there's two things that we're going to need to grab first before we do that. And one is the reference to the minimap, and the other are parameters from the material parameter collection that we set up in a previous episode. All right. So we need to start by getting our minimap reference, which again, we made it in event construct and we had set it, but we never did anything with it. Well, now we're going to use it. So you can drag it onto the screen, right click on it, and convert it to a validated get. We only want to run this logic if the minimap is present and if it's valid, because if it's not, then we're doing all this extra math and logic for no reason. But on top of it, we could also cause a crash. So we're going to go ahead and get it, convert it to a validated get, and only if it's valid do we proceed with anything here. Now, we need to grab the zoom and the size parameters from our material parameter collection. So we have this NPC minimap, which has variables for the size that the actual map was. So what the material for the minimap is taking in to display on the minimap, that's the actual size of the scene capture component 2D that was capturing that. Now, we also have an X and Y position, which updates all the time. This is just the X and Y position where either the player is, or you could use it for other things. But right now, it's the X and Y position of where that camera is panning over the texture. So we know where we're at on the texture. The zoom value is how far we are zoomed in to the minimap. Right now, it's defaulting to 0.5 because that's a good spot to test. Because if you leave it at 1 or 0, then you're going to see some weird results in some cases. So I left it at 0.5 halfway through. We haven't gotten into zooming yet, so don't worry too much. But just make sure you have all these here. And that's a little refresher on what they all are. Now, if we go back into the map icon widget, we need to actually get these parameter values. And so to get them, another refresher on this, you can just type get scalar parameter value. And you'll have to enter your collection. We only have one, so I went ahead and selected it, but you could have multiple. Make sure you grab your minimap one. And then you can select your parameters. We want zoom and size. Doesn't matter the order, we're going to need them both. So you can put size and zoom either way. And once you get them both in here, we have all the values we need to get started. So remember, this is the map icon widget. So this is the specific icon. So every icon is going to have a different location, assuming that the two characters are not directly on top of each other. If the icons aren't directly on top of each other, they're going to have a slightly different location at least. So we need every icon to figure out their location on the minimap. So here's where the math starts. So we have all of our data. Let's take a look at something. So first of all, we're going to need the size that we are working with here, because we need to know the size of the minimap in the widget, because if we make it bigger, the math changes. The more space we have to play around with in this minimap here, we have more room that we can move these icons around. So if this took up the entire space, but was the same zoom level, then we would be able to put icons all over this widget. So we have to know exactly what we're working with. So that's one of the reasons that I have the size saved out, because immediately we're going to be using that size. However, you could just hard code it either way. Basically, we need the 300 here, since that is the size of our widget. We're 300 by 300. So I'm taking the size from the material parameter collection, which is, remember, it's the size of the actual area that made this minimap. We're dividing that by the size in the widget. This gets the proper proportions, so we know how far away everything is from each other using this view, right? If you look at a map in real life, if you pull out a map, it is not as big as it would be to actually travel from one spot to another. It is just converted so that you have this ratio, this smaller version. It is proportionate, right? So a larger distance in real life is still a larger distance on the map, but it's going to be a lot smaller than if it's 20 miles, it might only be an inch on the map. Right, so there's that conversion. And so that's what we're doing here. We're getting that conversion, but then we also have to apply the zoom, because the zoom also changes that. If I'm holding the map farther away from myself, then the things appear as if they are smaller, and if they're closer together. But if I'm really zoomed in, I get more detail, then I can see that, oh, maybe this is a little bit farther apart, or everything's up close, right? I can really see the intricacies. So we need to change. We need to make sure we're factoring in both the actual size that we're seeing on the minimap on the screen, as well as how zoomed into it we are, because, you know, your zoom can also change. If you zoom into the minimap more at mid-game, we need to change the math. Okay? So we're taking the zoom and we're multiplying that by the result of the division from the size of the material parameter collection divided by the size of the widget. So this returns a value, and we're multiplying that by the zoom level. All right, now from here, we have another set of math that this is going to be used for, but let's start with this right here. Now we need to know where this icon should actually be, because we have the actual data, we have the size of the minimap, the size we're working with, but we still need to figure out where the icon should be. So we have this icon owner that we set up in the map icon widget right here. Remember, and that's what I was showing you earlier, it's how we can get the enemies to have their own icons. They're the owner of the icon. And so wherever that owner is standing, if it's the enemy, then they're standing in front of us. Wherever that owner is standing, we need to get their location. We also need to know where the reference point of the map is, because sure, we have the zoom, we have the size, but also when the player moves, we move the minimap around, right? As we move to the right, then we're shifting what's within the minimap's bounds. So we need to know both where the player is, or the point of reference for the minimap, which just happens to be the player. But we need our point of reference. So we're going to get their actual actor location in the world. So we want to get the owning player pawn. Okay. The owning player pawn, the minimap and all the icons on it are owned by the player that is controlling them, that can see the minimap on their HUD. So getting the owning player pawn is getting the character we are controlling in the game. Then we can use the icon owner to get the actual owner object in the world that belongs to this icon that we're setting up. Then we want to get the actor location for both of them. Okay, so quick example, we have get owning player pawn, and then we want to get actor location. However, with this, it's going to return a vector, which we need to do some additional math on top of it. So we want to right-click on the return value and click Split Struct Pin. This will give you the X, Y, and Z, everything that makes up the vector, so that we can do math on it. Okay? And then we want to grab our icon owner and do the same thing. We want to get actor location, and we want to right-click on the return value and split it. So now you'll have these nodes here. Now we have to get the difference in the location so that we know where they are relative to each other. And so we are going to subtract the X's and the Y's. We should never mix X, Y, and Z, so I shouldn't subtract X from Z unless I'm trying to get some weird result. Because right now, we just want to know the X distance apart and the Y distance apart. So we take the return of the X, do subtraction, then I plug in the return of the X from the icon owner. Okay, so X minus X. Then the Y should be Y minus Y. All right. Now we have our distances there, so we can judge where they are. We need to correlate this with the other data that we grabbed earlier. Okay, we need to use this value here, which determines where we're actually at based on the actual size and the zoom and all that good stuff. We need to relate that to the distance they are in the world. So we need to take the result of the multiplication and divide both of these values by it. Okay, so the return of the subtraction should be divided by the multiplication result. The return of the other subtraction should also be divided by the result of the multiplication. Now, there is an additional note here you'll see, and the reason for this is just flipping values. Let's say you ignore this node and you just did what I told you. Now, when you play the game, you're going to see as I walk closer to these enemies, something's not quite right. Okay? You can see that they are still close to me when I'm close to them, but they're moving the same direction I'm moving. Well, they're not getting away from me. They're staying in place. This is because if we don't multiply this by -1, we're getting the opposite value of what we really have when we're moving these. So they are reversed. This is reversing the operation. So multiplying by -1, which it's not going to let me undo, but multiplying by -1 fixes this issue. If you add this guy in here and plug that in the division, this orients the world the proper direction. So when we're doing math, we don't have to convert all of our individual components. We can just flip this one subtraction, get the appropriate direction we're working in. Now we'll have these two divides. By the way, to get the divide, float divide, you can either drag off a float, type divide, and you'll get this. Or you can actually type the slash there and get divide. That's what these are. Now you'll be down to just two results, two returns, return for each division. So with these, we can make a vector. The vector that we make is going to be the correct spot, the correct location, theoretically, of the icon. But it needs to also be at the correct orientation, not just position, but rotation around the player and around the world. See, as I turn and I walk other ways, you see that things change. If I'm walking away from them, then you can see that the icons are going up. If I'm walking toward them, they're going down. They're coming closer to where we're going. And so we need to be able to move them based off the rotation that the character is moving and the rotation of the minimap as well. Because even if the minimap's not rotating, like see how I'm walking away from it, the minimap doesn't rotate. At the same time, it still has to take into account where these icons can move and when they need to be clamped to the sides, because they can't move the same distance every direction and remain within the bounds of the minimap. Okay, so we're going to take both these results and make vector 2D, and then you just want to bring them in. X into the X, Y into the Y. All right, so whatever X subtraction you had that went into the division, that needs to go into the X, and the Y needs to go into the Y. If you do it reversed, then you'll get some funky results, so you got to make sure you do that right. Now from here I made another function because there's a lot more math, and this was a good stopping point, right? We now know we have a proper location and a vector we can use here. We have to still get it in the right spot on the map based on angles and where we're located on the map as the player, or really where the texture can be seen on the map, which just happens to correlate to the player's location. Anyway, long story short, we're at a good point to stop because we have a vector that we can use now and do other math on. So before we go any farther, let's make a new function that we can pass this into. So we can go ahead and make a new function by pressing plus function here. I called mine determine location on minimap, and that's because this is true. Even though we were determining a lot of the location here in this logic, we still are not done, so I think this is a fine name for it, but you can call it whatever you want. Once you make it, compile and save, and you'll be able to add input parameters. You can click plus to add these parameters here. And what you need to do is add one for the character and one for the icon. That way we know, again, where they're at in relation to each other, where they're at in relation to the angle of one another, and where they should be displayed on the minimap, depending on that angle. So again, if they're in front of me in the world, then we want to display them in front of me in the minimap, not just at the location that we found here. So we need both the character vector and icon vector. Now, in this case, the character vector is actually remaining all 0, so it's kind of pointless for me to put this in. However, it might not always be that way. If you've ever seen a minimap where it has actual boundaries, and the minimap will stop moving and the character can move to the end of it. So say you see how my icon in the minimap here is facing the bottom right hand corner. In some games, it will stop, the minimap will stop like here. It won't allow it to go any farther because you reach the edge of the bounds, and so the player icon could actually travel down here. In that case, you would have to update it and find the character vector at a different spot. However, in this case, we want it to just be 0, 0. We're keeping things simple because it's already pretty complicated, but we're keeping things as simple as we can here. So we're going to leave this at 0, 0, but it could be useful to have a vector for this. So basically, we want to make an input parameter for the character vector and an input parameter for the icon vector. Now, the icon vector is what we were figuring out with all this math. Okay, so make two vector 2Ds right here. Two of these guys. For the character, you can leave it 0, 0. For the icon, pass in the vector 2D that we just made with these values here. I explained all that without saying to call it, but make sure you drag it onto the screen after that, or search for it either way. Determine. But make sure you're calling it. Make sure you connect the white execution line, and then pass in your icon vector. And again, you can leave your character vector out for now. Now we have to fill out this function as well. Okay, so we're going to go into our function, determine location on minimap, and you'll just have this node to start. We still have to do all this logic, which probably looks pretty confusing, but it's not too bad. What we need to do is figure out the angle. Like I said, we need to find where it should be displayed in relation to other things on the map, in relation to something like the player or the world directions. So we're going to take the character vector and the icon vector that we grabbed to do this. So if we break both of the vectors, I know we just made a vector 2D, but if we break them again, you have your character vector, drag off, break vector 2D, and then you also have your icon vector that you can drag off and break, and you get these two nodes right here. So if we take our character vectors x and subtract our icon vectors x, then we get a result here, and then we're going to also take the character vectors y and subtract the icon vectors y and get a result here. Now we're going to do a tan 2, and we want to return degrees. Now a tan 2 is the inverse tan. We want to do this because this is the inverse tangent, which will return an angle. And so we have to pass these things in the right way because tangent is opposite over adjacent. We have to take the result from the y's, the subtraction of the y's, and pass that into the y parameter on the inverse tangent here, which is the top parameter. Okay, I know sometimes it's x and y. This one's y then x because it's opposite over adjacent, and so mathematically it makes sense for it to be y and x. So like I said, you pass the y in there, but the result of the x minus x goes into the x, which is the bottom parameter. When you do this, you'll get the angle in degrees that we have for where that icon should be placed. So once we have the degrees of where the icon should actually be, what we need to do is determine how far away it is and where to display that based on that angle, okay? Because yet again, we had the position of the icon and where it was going to be in the world, or where the owner was in the world, and where that icon was going to be represented. But then we had to get the angle to display where it should be in relation to where the player is, or really where the map is looking at, right? And now that we have that angle, we need to figure out the distance to display them on the map based on that angle. In a 2D scenario, if you have an object that is 10 meters away from you, if it is 10 meters in front of you, not horizontal at all, just 10 meters in front of you, it is going to be farther than a diagonal line that is 10 meters in front of you. This is because this counts horizontal and vertical distance. So we need to also grab the length of the vector of the icon so that we can figure out where it should be and its distance should be in relation to the player, so it's in the right spot using the angle and all the other things that we set up before. So we can drag off the icon vector right here, and we can type vector 2D length, and this will return the length of the vector. Simple enough. And so that's going to be the distance that this vector actually equates to. All right, now what we have to do here is make sure that we can put the objects in the bounds of the minimap now, because as I was just saying with that example, we don't, if certain objects fit within all the parameters and they would otherwise be off the map, we want them to be in the map. Okay, we don't want them to just be off the map. So what we're doing with all this logic is we want to make sure that we can clamp this object so that the icon should be shown on the minimap. Again, in this case right here, it could actually be they are out of the bounds, out of the range of the minimap, but you're still seeing them. That's because I've clamped them to be on the screen there. However, you could get it where you can have them disappear when you get so far away. We haven't gotten to that point yet. But regardless, if you're doing this here or not, we do need a limit to where they are not on there anymore. That's what we're trying to figure out, because it's not just about if they're on the widget, because right now we have the angle, we have the location, but if the object, say, think of this as the minimap. This is the minimap. Think of this entire thing as the minimap. So say the icon is all the way up here. This is like a far away location where my mouse cursor is now. Well, we don't want that displaying on the minimap all the way up here. This is this is on the HUD, this is on the character's screen. So we need to either limit them to where they disappear after they go out of bounds, or they need to get clamped here to the edge. Either way will work, and some could be different depending on your game. You could have some icons that do one way, some that do the other. Doesn't matter. A good example is like the primary objective icon. If you have like a waypoint of where the next quest mission is, you would have it to, a lot of times it'll be kind of locked here where you can just follow the icon and keep walking toward it. But all your enemies and stuff are going to disappear when they get to the edge, not to crowd this minimap. So that's what we're trying to cover in this part. That's what the length is used for, is we're going to have how far this vector is, right? How long this vector is, so we know where it's going to be placed. But we need to clamp it to a value that makes sense so it stays within the bounds we want. Now, there are two ways to do this. Again, you could use a hard-coded value, or we could use our variable. Since we set up the variable, I'm now going to swap it to that, but I'm going to explain the math behind it first. So we want to take our length and we want to clamp this value. Okay, because we don't want it going, like I said, outside the bounds of the minimap. And in fact, you know what? Let me show you actually what happens. I think this will make more sense. So see how these objects are going out of the bounds of the circle? Now they do still have a maximum length. You see how they're going out of the bounds of the circle? This is because they're not clamped to the section that we're in, right? They're just clamped. They're not clamped to a value. So any value they are, they can go to that. Well, that's not good. We don't want to do that. That looks ugly. What we want to do is clamp these values. That way we can give them maximum range in the minimap without going outside of it. And to accomplish this, we can use the radius of our minimap. If I make it too small, you'll see they can't quite go to the edge. It almost looks like they're following me. They're staying in place, but you can see how the icons are kind of staying here. And this is because the radius, or the clamp that I gave it, is too small. It's smaller than the actual radius. So this value here in the maximum should be the radius. Okay, so drag off your vector 2D length, type clamp, like I said, and we want clamp float. Now, the minimum is 0, because we don't have negative values here. And we want the maximum to be 150, because our widget on the character HUD was 300 by 300. However, alternatively, there's something else we can do. Our minimap now has a size in widget variable, and we actually use it in other places, so we might as well use it here as well. If we grab our minimap reference and grab the size in widget, we can multiply it by 0.5, which is faster than dividing by 2, so might as well be more efficient when we can. But you could also divide by 2. It's not going to hurt you too bad. And we want to plug this into the maximum. You'll see that this will, of course, still work because it is 300 divided by 2, or 300 multiplied by 0.5, which is 150, which is the value I had. Okay? So you might as well do it this way as opposed to the hard-coded value, but I think that makes sense logically why that is going on now. Now let me actually clean this up a bit because it is a little bit ugly. And so now we are back. So I have my vector 2D length. I have my minimap reference size and widget multiplied by 0.5 going into the max of the clamp here. And the rest is the same. So let's go over this. So now the result of the inverse tangent returning degrees. Remember, that's the angle. We're going to use that now because we have to know where it should be on the minimap. We can use the angle of where it should be in relation to the player or the center of the minimap, but the angle alone is enough. We need the angle and the location. So we need to grab that value, where it's going to be at, make sure the distance is correct. And to do that, we can use our angle and we can use some more trigonometry, sine and cosine, to accomplish this. So drag the return value out, and they're both going to go into, one's going to go into sine degrees, one's going to go into cosine degrees, because we have two different sides here. We have a horizontal and a vertical we have to deal with. Okay, so if you drag off this value, you type sine, and it will come up, but you want sine D, sine degrees, and same with cosine. Type cosine, it'll come up, but you want cosine D, cosine degrees. Alternatively, you can type in cosine D, and you'll get these. Make sure you don't choose the A, because A is inverse. Okay, so you just want sine D and cosine D. So this is going to perform sine on the degrees value and cosine the degrees value. From here, we have to multiply it by the clamped value that we got here. If we take this return value and multiply it by the result of the sine, we're going to get the actual final location that this should be on the minimap, where it should be on the minimap, because we're taking the angle, we're taking the distance that it is away, we're doing trigonometry to get the other side of where this would meet to figure out where this icon should be in relation to where we're at on the texture, or in other words, where the player is at. Okay, so we need to do this right. So we need to multiply the result of the clamp by sine. There's another -1, so you can probably guess what it does, but I'll just go ahead and show you. And so as I'm walking here, you can see things aren't quite right. So this is inverted again, okay? So this time it's the X that's inverted on the render translation, not the Y. So make sure that you, after you did this multiplication, you do another multiplication to multiply it by -1, reversing that value. That way it's the proper value. And then you're good to go. Okay, you don't have to do all this yet. I'll explain this in a second. Just make sure you get to this node right here. Now, we also have to do Basically the same thing for cosine. It is a little bit different in this case because, of course, sine and cosine are different operations. But really, we're calculating the same thing here. We're just calculating an x and a y. Sine calculated the x. Cosine is going to calculate the y. So we take the return value again. Say I have reroute nodes routing it down here. And multiply this by the cosine degrees. Then multiply that by -1 because guess what happens? I'll show you again. Guess what happens if we don't do it? You're going to see that this is going to be inverted, and they are behind me. They still get closer as I move up, but not the other way around. Quick note, this is because in the world, moving things up changes the Y location, or really the Z location, in this case, from 266 to 386. It brings it up, right? But on a texture and on UVs, 0, 0 is up at the top, so as you move down, like if this is 0, 0, as I move down, then the vertical section gets higher. So this could be 0, 0, 0, this could be 0, 1. And so we have to invert it. All right, and now we have two nodes here, or we have this node here and this node here. Okay, and now you see I have two repetitive sections here, right? All this is repetitive. Well, do we need this? So actually we don't need this. This is what we were doing in our third person series, and this is what I was telling you about that's different with the squares. So this value here that I'm clamping, I did not clamp it here in the third person tutorial series because it was not required. I didn't have to clamp this value here because I could use all the space that I had here. But since we are using a circle, we need to clamp it differently. So I did them in different spots. Those are the differences. I'm going to get rid of this. So don't worry, I'll clean it up. It'll make more sense. But I'm going to get rid of all this right here because we've already clamped the values. And I'm going to get rid of all this right here. Okay. And now I'm going to bring this over here. Make sure that this is still where it should be. Yep. And we want to grab these and put these in the right spots. So we have X here and Y here. Just like that. And this is the final result right here. So you can see there are some differences between the third person and the FPS, or at least between different shapes or different types of mini-maps. But the last thing we want to do now is just take our -1s and plug them into something called set render translation. So if you don't do this part right here, then pretty much everything is for nothing because we haven't actually moved everything. We got all the data, we grabbed everything, but it's never being set to an actual location. So you got to make sure you do this part before you see anything. Now, this is basically a location. I did show this in the third person one, but essentially this image and anything on a widget, if you scroll down, has something called a render transform. There's no location in here. You can't like actually set a location. But there is a render transform. Transform has translation, scale, shear, and angle. We don't care about almost any of those right now, but we do care about the translation because that's where it actually moves to within these bounds. So, set render translation is what we want. When you get this, you get a vector 2D. So you could either make a vector 2D with your two values, or you could right-click and split the translation to get an X and a Y, and then you pass in the X and pass in the Y. Again, the alternative, if you wanted to, is to not split this value, and then instead make vector 2D, just like we did outside of this function. And then pass this translation into the set render translation right there. And now when we play this, compile and save, we will be able to see our icons moving the proper direction. Okay, they're going to move left and right, up and down, and they're going to get clamped to the edges. That way they don't go out of bounds of the circle. So there you go, guys. That's how you can make your mini-map with icons that actually move and go to the proper locations in the mini-map based on where the owners are in the world. But that's all I got for you, so thank you so much for watching. If you enjoyed, please subscribe. It does more for myself and the channel than anything else you can do, so I'd really appreciate it. I want to give a huge, huge shout out to my YouTube membership, Patreon members, supporters, and subscribers. Thank you all for everything you've done. I'm incredibly grateful. I really, really enjoy working on these for you, and I am so happy, so excited that you guys are also as excited about these as I am, and I really appreciate all the support that you've given. Thank you so much. If you had any issues implementing this tutorial, and I know it was a tough one, feel free to join the Discord community. I'd be happy to go over it with you, get everything sorted. Anyway, guys, that's all I got, so thank you so much for watching. I am Shawnthebro, and I will see you in the next one. Goodbye, guys.